Good morning all of you. Today we will discuss about a topic that is binary tree traversal, which is an important part of non-linear data structure. We will have a discussion on this. Now before going into the topic, we must understand what is a traversal or a tree traversal. Now tree is a collection of nodes, and the traversal means we have to visit each and every node at once, and we have to process those nodes without making any kind of repetition of those nodes. Okay. If we broadly classify the tree traversal, then we can have three kinds of traversal, that is pre-order traversal, second one is our post-order traversal, and third one is in-order traversal. Now, after you visualizing those terms like pre, post and in, you can remember we have covered a particular chapter in stock data structure where we have some expressions and we are representing those expressions in the form of in, pre or post fix notations. So from pre we can write prefix. For post order traversal we can write postfix, and in order can be related with infix notations. Now just remember, if there are two operands, let's say AB, and we want to add those two operands, and we are interested to make a prefix execution of those operands, and then we can write plus AB as the prefix notation for adding A and B. If we are interested to make the postfix evaluation of these operands, then we can write AB plus as the postfix notation, and if we are interested for infix notation, then we can simply write A plus B. Now let's represent this infix notation in the form of a binary tree. So very simple, take the root as the operator, left operand will be taken as the left child, and right operand B will be taken as the right child. Okay. So with that, let's understand how this pre, post and in-order traversal of the tree is related with these three notations. First one is pre-order traversal. Okay. Let's take one example of a binary tree, A having two child B and C, B having two child D and E, then C is having two child F and G, G let's say having one child, let's say H. Now if we will see this plus AB, we can write the algorithm for pre-order traversal as visit the root. Second one is visit the left subtree. Third one is visit the right subtree. But important point is what? We can make this traversal of left subtree and right subtree recursively. Why recursively? Because the left subtree and right subtree both are itself one tree, and they are having root node, left child and right child. So we have to make this recursively. Okay. So if you follow this algorithm for this pre-order traversal, then tell me what will be the outcome of pre-order traversal. So first we will traverse the tree from root, because plus AB, you just remember plus AB. So outcome will be like this. A will be taken as the first node. Then after we will visit the left child or left subtree. In the left subtree we can find another independent tree. So we can write the root node of this tree, that is B. Visit the left subtree or left child, that is B. Then after the right child, that is E. Once this left subtree has been completed, we made the recursion, then we will go for the right subtree part. In the right subtree we have a root node, that is C. The left child for this root is F, we are having F. Then after in the right side we are having another tree which is having no right subtree. So we will write the root node first, that is G. Then after the left child, that is H, and there is no node. So we have completed this tree traversal, that is in the form of a preorder. So we can count 1, 2, 3, 4, 5, 6, 7, 8. Total 8 number of nodes has been visited in the form of a preorder traversal. Right. Let's look at the post-order traversal. This has been completed, and see what will be the outcome of post-order traversal. Now if you write the post-order traversal for this tree, just remember the concept will be what? A, B plus. Okay. Now you tell me what will be the outcome of AB plus format. That means first we have to visit the left subtree. In the left subtree we are having another tree, right? So we will first visit what? The left of left subtree. So we can write B first. Then after the right part of this B rooted tree, that is E. Once this has been completed, we will go for the root node, that is B. Okay. This has been completed. Now we will go for what? This part recursively. Now in this part we are having another tree. We will start our journey from leftmost, that is F. Then after we will visit what? The right part. In the right part we are having another tree. So we will visit the left part of this tree, that is H. There is no right subtree, so we will visit the root node, that is Z. Once this has been completed, we will go for C. Just count whether we have covered or not. We have not covered. Why we have not covered? Because we left this root node. This is the root node of the total tree. We have not written here. So now we just see whether we have completed or not. Yes, 1, 2, 3, 4, 5, 6, 7, 8. We have visited all 8 nodes. This is the post-fix evaluation or post-order traversal of the binary tree. If you will see the in-order traversal, this is very much interesting. Just see, let's say this is in order. The format is what? That is A plus B. That means we have to visit the left, then the root, then the right part. So we will start our journey here. The left part is what? D. So we will write like this, D first. Then after the root node, that is B. Then after, very easy, that is E. Once this has been completed, we will go for the total root of the tree, that is A. Now we are having what? The rightmost tree of the total tree, the right subtree. In this case, we are having a node, that is C. We will start our journey from left part. We will write what? F here. Then after the root, that is C here, isn't it? Yes. Then after we are having another tree, that is Z, but we will start our journey from H for this tree. So we will write H here. Then after G. Now see whether all nodes have been visited or not. Yes. 1, 2, 3, 4, 5, 6, 7, 8 without repetition. That means we have visited all the nodes by means of in-order traversal. Okay. Now, if I will write the things in the form of a procedure, then how can I write the procedure for in-order traversal? Now tree is a collection of what? Nodes. So node is a structure. If we represent this structure in the form of a linked list, then we know that this is the data part, this is the left, this is the right address of the neck. That means this is the left part of